ladies, so now that we know how to name ions, we're going to start writing the formulas for ionic compounds. So whenever we are looking for ionic compounds, we want to kind of look at some interesting portions of it because sometimes they are called binary ionic compounds. So whenever we're determining the formula for a binary ionic compound, you're going to go through a set of specific steps that will help you figure this out. Now, bi means two, so that means in this kind of compound, we're going to have two elements. That is the main key here. Whenever we are looking at these binary compounds, we're going to have two things that we are looking at. Before this French chemist figured out a nice naming system, they just started to kind of guess what was inside of stuff. However, it was impossible to memorize all these different names. So instead, he developed a system and a method for naming these chemical compound. And we're going to use the same type of naming system that he used. So whenever we're looking at binary compounds, we're going to look at these two elements that are ionic. Okay, so anytime you're thinking of binary compounds, we can have a different type. However, we're not going to look at these in this chapter. So if we are looking at a binary ionic compound, we need to write the formula by first writing the symbol of the cation, then the anion. We will then add subscripts as needed to balance out those charges. And remember, the total charge of a compound is always going to be 0. We want those charges to cancel out. And anytime you're thinking about writing out these types of formulas, once again, your cation will be the first one and your anion will be the second one. So let's try and write the ionic compound for potassium chloride. So potassium is the first one shown here, and chloride is your second one, meaning it must be that anion. So if you have the potassium, which is a K+, and your chloride ion, which is Cl-, you grab those charges and cross drop down just like we did in lab, and you get KCl. And so they're combining in this ratio of 1:1 to cancel out those charges. So that cross drop down rule always is going to work. However, sometimes they give you some different types of charges. So anytime you have a transition metal, and that's going to be in the drop down box of your periodic table, the transition metal, its charge is going to be in as a Roman numeral. So the charge of this example here is 3. So 3 I's together means the number 3. Now oxide, that comes from your periodic table as well. And you know that anything that ends in IDE comes from your periodic table. And oxygen, if you were to write the group number, just like we did in the last screencast, its group number is 6 subtracted from 8, giving you a -2 charge. So now we know the charges of both of these elements. So let's go ahead and write the formula. So we have iron 3+ and oxide, which is O2-. And we're going to grab those numbers, cross drop down to give you iron 2 oxide. And here it is as well, if you want to look at it in a little bit longer drawn out, a little bit neater of a method. So here again is this idea of the cross drop down, which I've showed you before. However, if you need to check to make sure that your combination gives you the neutral charge that you want, you would take how many, or the number of ions that you have, times the charge, and add it to the number of anions times your charge once again. And when you add those all together, it should give you a nice 0 because they are canceling out. So remember, one thing whenever you are writing your compounds is that the charges are dropped, the signs of the charges are dropped whenever you cross them. You are only grabbing the number, not the charge. So the charge, again, of the formula is going to be 0. So notice here, there's no charge indicated. That's because we've added enough positives and enough negatives to cancel those out. Now, one thing that we haven't run into yet is when you have the same number on the bottom. So if we have a calcium ion and a sulfide ion, whenever you cross drop down those two, you're going to get Ca2S2. However, we want to always write the lowest whole number ratio. So if we wanted to do that, just like in math, we're going to reduce to give us, if you divide both of these by 2, CAS. And just in case you wanted to check, we could take how many cations we have times the charge and add it to the number of anions we have times its charge. And we should always get 0 because our compound is always 0, no charge there. So let's try a few. Let's look at copper 2 sulfide. So remember, anytime you see this Roman numeral, this is the charge. And then we have sulfide. Sulfide is going to be on your periodic table. It's in group 6, so you take 6 minus your total number of 8 to give you a -2 charge. So we're going to now write our copper, Cu, 2 plus, and sulfide, S, 2 minus. Now we're going to grab those two, cross drop down, and we would get Cu2S2. But hold on, we need to reduce because we always want that lowest whole number ratio to give us CuS. Now let's look at potassium nitride. That would be, let's give us a little bit more space here. So I'm going to erase this one. So we have potassium, which is K plus, and nitride, which is N3 minus. Again, nitrogen is in group 5 minus 8 would give you that -3. That's where that comes from. Now we're going to grab each number, cross drop down, and that's going to give us K3N. And with that, we don't need to reduce because you can't reduce to any whole number ratio. And again, this is always going to be drawn out in your notes as well so that you can follow along in a little bit neater of a manner if you need to. Here's how you can check the charges for your final 2 ions. So once again, you write how many of your cations you have and the charge of each of those, and then you write how many anions you have as well as the charge. Overall, that should always equal 0 because your charges are going to balance. So overall, if you know the formula of your ionic compound, you can always write its name as well because you always know the charges of each thing based on your periodic table. So first things first, you want to make sure that you have a metal and a non-metal. And don't worry, that'll always be the case on this test. But when it comes to your midterm, you have to make sure that you know that you are combining a metal and a non-metal. So to name any binary, again, bi means 2, ionic compound, you're going to take your cation first, just like how you write the formula, followed by the anion second, just again like you write your formula. So let's take a look at an example. Here we have CS2O. It's composed of 2 things, so we know it's a binary compound. So if we look at our periodic table, CS is cesium and oxygen is an O. So we want to make sure that we start by naming the cation first. So the cation would be cesium. And anytime you have that, your cation, you're just going to name it just like it says. So here we have cesium. Then you would take your second one, which is oxygen. You take the first syllable and then add IDE. So if you look at oxygen, your first syllable is ox, and then you add IDE. So overall, you have your cation being named first, your anion being named second, for a total name of cesium oxide. So let's look at NABR. Again, you look at your periodic table to figure out what Na stands for. Na stands for sodium. And then you would take your Br and find out what the name of that one is, and that's bromine. So to name your compound here, you would take your cation, which is always going to be the first one, and that is sodium, and followed by this word, bromine. But again, you take the first syllable and you add IDE. So that's going to be bromide. That's your total answer. See how you have that IDE at the end. One last example is here is SRF. SR is going to stand for strontium. F is going to stand for fluorine. So to name it, you first name your cation, which is strontium. Then you would name your anion, which is fluorine, but you only name the first syllable, then add IDE, so it would end up being fluoride. So one problem that we sometimes run into is when you want to try and name a transition metal. The reason for that is they can have multiple charges. So we want to make sure that we tell them exactly the type of charge that your ion or your cation is going to have. So once again, you would have to name it just as you would from your periodic table, but you have to add a Roman numeral. So we have to figure out how to get that Roman numeral for the right charge. So we have to figure out, all right, we have one copper here and one oxygen. Now, oxygen always has a -2 charge. So what must copper be in order to cancel out that -2 charge? So if we were to write out that formula of how many cations I have times its charge, plus how many anions I have times its charge, equaling 0, because that's always going to be our final answer. Your X must equal a +2. That's the same for our copper. Our copper must have a +2. So in order to show that in the name, you would write out the name written on your periodic table with the Roman numerals of 2, because that's the charge, followed by oxide. Remember, O stands for oxygen, but you drop off that second syllable and add IDE. So anytime you have a metallic element in that binary compound that is a transition metal, you must use those Roman numerals for your cation name. Again, your cation is always going to be the first one listed, and your anion is going to be the second one listed. Look at these binary ionic compounds to make sure we know how to name them, and then we will be all set. So first we have, I think that's cobalt and iodine. So first thing to notice is that cobalt is a transition metal. So we have to figure out what the charge of it is. So we write how many we have times its charge, which we don't know, plus iodine, which we have 2 of those, and iodine's charge, which is -1. And once again, that's always going to equal 0 because it is a neutral compound. So if you were to solve for X, X would equal a +2. So whenever we write this, we're going to first write our cation, then our Roman numeral, the anions. You would get copper to iodide. A little easier since it is not a transition metal, so you would name your cation first, followed by your anion with IDE. So you would get lithium selenide. That does it for me. See you next time.